In our work so far, we've used our groups of units, mod, whatever, many times as examples to illustrate ideas. And in the context of external direct products, we have a few results that apply to our groups of units. And to introduce those, we need a new definition, one new idea. So let's look at our definition right here on page 63. Suppose K is a divisor of n, then we want to define a new group U sub K of n to be all the elements in our group of units mod n, such that x mod K is equal to 1. And it can be shown that this is actually a subgroup of Un. So we want this new group. So let's look at an example, what we're talking about. If we are looking at U15, for example, units mod 15, that is 1, 2, 4, 7, 8, 11, 13, and 14. All the relatively prime numbers mod 15 with 15. And we can look at U2 of 15, for example. So that would be all the numbers x mod K in this case is 2 is equal to 1. So that 1, what else? 7. It's all the odd ones, right? So it's 1, 7, 11, and 13. Or we could look at U3. There we have x mod 3 is equal to 1. So that's 1. What else is in there? 4, 7, and 13. Everything that's 1 bigger than a multiple of 3. Or U5, let's look at that. That would be 1 and 11, and I think that's it. Everything that's 1 mod 5 in our group U15. So with this new definition, we get theorem 8.3 that says, suppose you have two numbers s and t that are relatively prime, then the units mod s times t is isomorphic to the units mod s plus the units mod t. And moreover, we have that u sub s of s times t is isomorphic to ut, and u sub t of s times t is isomorphic to u of s. So in our example that we just looked at, what can we say about U15? Well, that's, for example, isomorphic to U3 plus U5. And the moreover part would say, for example, that U sub 3 of 15 is isomorphic to U5, and U sub 5 of 15 is isomorphic to U3. And then we also have a corollary that generalizes this to more than just two groups. So if we have M is equal to N1 all the way through Nk, where the n's are piecewise relatively prime, then we get the isomorphism between U of M with the external direct product of all the smaller u's of N1 plus U of N2 and so on through U of Nk. To prove this, if we wanted to prove this, theorem 8.3, theorem 8.3, we can show that we have an isomorphism from one group to the other by taking x mod s, so by taking an element x in our group U of st to the element x mod s, comma, x mod t. So we'd have to show that this is an isomorphism. because that one would go from UST to U of S plus U of T.